This was question number 4 on the quiz, and part of the question that I want to address here is how to find the domain of this function. This is something that we are all capable of doing. It just took a little bit of extra thought. So there are two things that we know of right now that we have to exclude from the domain. One is I cannot have 0 in denominator. And 2, I cannot have no negative numbers under an even root. So I cannot have -1 under a root. I cannot have any negative number under a root of 4, a root of 6, a root of 8. If I have a negative number under a radical sign, I'm taking an even root. It doesn't work. It's not a real number. So I need to figure out then, what is the domain for this problem? Well, there is no denominator, so I don't need to worry about that. But I do have an even root, and I do have a radical sign. And I know that whatever is under the radical sign cannot be negative. So it has to be positive. It can be 0. It has to be 0 or positive. So I can set 5x plus 3, which is what is underneath my radical sign, as greater than or equal to 0. That is telling me that this thing right here underneath my radical sign has to be 0 or a positive number. Now it's a simple inequality. I'm going to subtract 3 from both sides, and I have 5x greater than or equal to -3. And then I'm going to divide both sides by 5. And I get x has to be greater than or equal to -3/5. That is my domain. So if I write my domain like that, I would write -3/5, comma, infinity. And let's just take a look at the graph and see if that actually works. So I've called up my calculator and I've entered in the equation. I want the 4th root of 5x plus 3, and I wrote it as 5x plus 3 to the 1/4 power. So let's look at the graph. So zoom 6. We can see that the graph has started a little bit to the left of the y-axis. Let's zoom in on it a little bit more. Let's see if I can do that. Zoom in. There you go. You can see that a little bit better. You can see that my graph here is starting, my first x value is about -3/5. So that's kind of proof of the domain on this problem.